Good morning, Algebra 1. Today's lesson is all about similar figures. Alrighty, similar figures actually goes along with the lesson that we learned yesterday, which was all about proportions. Alrighty, so what I want you to do first and foremost, make sure you have your pencil and your paper out because we have several definitions or I have several definitions that I need you to write down. And of course, we're going to work things out together. So I want you to be prepared for that. Now, with similar figures, let's look at these pictures because our very first question is, or should be, what is a similar figure? What are these elusive and wonderful things? Okay. So if you look at these pictures I have pictures of animals as well as objects. All right, notice that I have two elephants, two cars or two race cars, two giraffes, and two cubes. Okay, notice first and foremost that each of these animals and objects are exactly the same either animal or the same object or the same shape. Okay, so notice these two elephants have the exact same shape, these two cars have the same shape, these two cubes, same shape, and these two giraffes are the same shape. Now, the one thing that they don't have in common is their size. One is smaller than the other. So that gives us a very good hint, a very important hint to what a similar figure is. Here's a definition. A similar figure or similar figures have the same shape, okay, but not necessarily the same size. So if I have a square, a small square, and a large square, those are similar. Or if I had a large square and a little small square, those are also similar. But now, did you notice it says but not necessarily the same size? That means they can be the same size, right? I can have two same size squares, but they don't necessarily have to be. In fact, most of the times when you see similar figures, you're going to see one smaller than the other, or in this case, one's larger than the other. Okay, very rarely have I, in books, textbooks, and things like that, have ever seen one that where they were exactly the same size. Okay, because that really gets into another term that we're not talking about today. Now, another important definition is the definition for similar polygons. All right, now a polygon, you already know what a polygon is. It's a shape with multiple sides. Similar polygons are polygons in which the corresponding angles are congruent. Congruent means same, okay? And corresponding sides, okay, important term, corresponding sides are proportional. All right, and really in order to really discuss proportional, you have to kind of see it with your own eyes. Okay, so now let's get on to our very first example. So we have here two right angle triangles. All right, two plain beautiful right angle triangles. Now if I were you, I'd probably write this down or draw these shapes. That way you would have some good notes if you need to look back for your homework tonight. Alrighty, so we can see that one is smaller than the other. The first thing I want to do, so that I can distinguish the two triangles other than saying look at the little one and look at the big one, I'm actually going to give them a name. And I don't mean a name in the traditional name like Bob and Sally and LaQuisha or any of those names. Name though, but I mean in terms of letters. Okay, so I'm going to call this triangle A, B, C, and I'm going to call this triangle, switch colors, we're going to call this triangle X, Y, Z. Now the letters that I've chosen in and of themselves have no real importance. Okay, I could have picked D, E, F. I could have picked the three letters of my initials, A, L, B. I could have picked anything I want as long as it was three, enough to cover each of the vertices. And as long as I named them in the exact same order. Notice I went from left to top to right. And when I named this triangle right here, I went from left to top to right. Make sure that you keep them named in the same direction. You know, don't go from left to top to right and then from right to top to left. That actually would mess up your proportions, especially when you're naming them. Okay. Now, another thing that we're going to do, let's talk about some of those keywords that I told you. If you remember, a few seconds ago I said corresponding angles are congruent and corresponding sides are proportional. Okay? Now, a congruent angle, let's start with the first one, congruent angle. Congruent angles mean it's the same exact angle. So if I'm looking at angle A, and I'm just going to draw the common line that you use for angles, right? Okay, if I look at angle A, then my question would be, well, what or where on this triangle is there an angle that's exactly the same or congruent to angle A? Well, if I'm looking on this triangle, it's not this one. It's not this guy. It is this guy. All right. He is in the same position, right? They have the same. If these were actually, if I were to put like a number in there, I could put 45. This would, let's just pretend this is a 45-degree angle. Well, then this would be a 45-degree angle. That's what we mean by congruent, meaning they are the same. If this was a 50-degree angle, this guy would be a 50-degree angle, congruent. Okay. All right. So now I've already drawn one line to represent angle A. So that means I need to draw two lines for angle B. Well, where's his congruent friend? Well, of course, it has to be angle Y. All right, and then of course this guy right here, which we know is more than likely, it's not drawn in here, but more than likely it looks like it's one of those special angles. It's the right angle. Uh, we're going to draw three lines when talking about him because he's the third side. And what is the congruent angle for angle C? Well, that would be Z. 1, 2, 3. All right, so how do we write this? I mean, if you were talking to a mathematician, and I mean, you wouldn't necessarily want to have to draw these. So there is a way, a short way, instead of drawing them out like a kindergartner, we have a way of writing them so that you could say the same thing, but without having to draw them. All right, so for instance, let's start here with angle A. Now, first, I'm going to use the symbol for angle, which is just like a slanted L. So I have angle A, and then I'm going to put his congruent side, which is, or congruent angle, which is angle X. Alrighty. And then I need to tell the people, I need to tell someone who's looking at this that these two are congruent. So I'm going to put a squiggle line and then two straight lines. Alright, so what that says is angle A is congruent to angle X. All right, I can set this up for all three angles. All right, so angle B, and who's his congruent side? Angle Y, angle Y. All right, squiggle line, two straight lines. Angle B is congruent to angle Y. All right, the last one, angle C, is his congruent side, angle Z, and they are congruent. All right, so these are congruent sides. Okay, that's how we do that. Now, in addition to talking about, or excuse me, I wrote the wrong word. I mean congruent angles, not sides, because they're not sides. Okay, so congruent angles. Now, in addition to talking about congruent angles, I can actually describe the sides or discuss the sides in the exact same way. All right, so those are corresponding angles. Now, the other word that we discussed in our definition was corresponding sides, and we said that those sides are proportional. Okay, corresponding sides. Now, I'm going to use a crayon, which I probably won't color very straight. That seems to be my habit. But I'm going to color these sides that are proportional. Proportional, in this case, when I'm looking at two similar figures, a proportional side, first off, is a side that is facing in the same direction. All right, now I could, if I wanted to make this more difficult, I could flip this shape and twist it all around, but we'll keep it simple for right now. So if I'm looking at side A, B, okay, I'm coloring that one red. The proportional side for AB would be X, Y, okay? And so if I wanted to write that, I would say side, and notice a side is nothing but a line segment. So I'd say side A, B, there we go, is proportional to, remember we use the equal sign for proportion. So side AB is proportional to side X, Y. Alright, so notice I went from A to B to X to Y. Okay, so keep it in the same direction as usual. All right, and then if I wanted to, let's do side BC. Let's see, I'm going to use blue. All right, so side BC's corresponding side would be YZ. Okay, YZ. So if I wanted to write that down, I would say that side BC, oops, gotta change my pen. There we go. Side BC is proportional to side YZ. Okay? And of course, the very last one, the very last side would be side AC, which is proportional to side XZ. Now, what I would suggest, is so that you can remember how to say these, okay? Because I don't want you to, if I were to ever, or another teacher was to ever point to one of these phrases or one of these, proportions like this, I don't want you to say, okay, line AB equal line XY. I don't want you to do that because that's incorrect. So what I want you to do is I just want you to write this in sentence form. I'll show you in a second. So I said side AC is proportional to side XZ. All right, so watch what I do. So side AB, side AB is proportional, and you know me, I love my abbreviations, proportional to side, XY. All right, so notice how I went from a symbol, a more symbolic form, to a word form. Okay, so I want you to just kind of take a few seconds to do that. That way, when you look back and you want to practice, you want to be able to say it correctly in class, which I know all of you are diligent, you want to do that, you'll remember how to do that correctly. All right, so like I said before, if you need a second to pause and do that, go ahead and pause the video, then continue on. Alrighty, now, so we've covered our corresponding angles, we've covered which are congruent, and we discussed our corresponding sides, which are proportional. Now, one small thing I did leave off, and that is, how do we tell someone that these triangles are similar? Okay, there is a symbol for a similar triangle. So first off, what did I tell you the name of this triangle was? Well, it is named triangle, notice I have a triangle sign, ABC. That is his name, triangle ABC. Triangle ABC is similar to, and I just use one squiggle line, to triangle XYZ. So triangle XYZ. All right, so write that in word form also. So triangle ABC is similar to triangle XYZ. All right, so notice, that's what I'm saying. When I have something written like this, the proper way to read it, the proper way to say it is triangle ABC is similar to triangle XYZ. Alrighty, now let's get on to the fun part. Are you ready? Because I know I am. Alright, so here we have another definition. Now this is where things get a wee bit tricky. Actually, no, let's not go to that definition just yet, because I want to show you something really quickly. Alright, let me get rid of all of this and erase all of that. Alright, let's say, and this is really, now it's nice to be able to name a triangle and all those things, but that is not our main goal. Our main goal for these triangles is to be able to look at these, or in this case they're triangles, but in similar figures I should say, is to be able to look at these figures and to work with these figures. Alright, so say for instance that I know that this side right here is 7, meaning, and I could say 7 centimeters. Right, and this guy right here is 14 centimeters. Let's say that this one right here is 10 centimeters, and this side right here would be 20 centimeters. And, whoops, got a little, there we go, let's fix that up. So 20 centimeters. And let's say that over here we have 6 centimeters. And this guy right here, we don't know what he is. He is unknown. And actually, I wouldn't use a question mark. I would use Since we are Algebra 1, and this is not 7th grade math, we will use a variable, which is x, to represent that we don't know what his value is. All right, so now this does have real-world applications, and we'll talk about some of those at the end of the video. But let's just focus on how do we find this missing side. Now, remember what I told you. Yesterday, or Friday's lesson actually, was all about proportions, okay? So we can use that same knowledge of setting up a proportion to solve a missing side problem. All right, so now what I need to do is I need to put my names back on here. This is A, this is B, C, and I said this is X, this is Y, and that is Z. Alrighty, so if I want to set up a proportion, okay, first off, and this is the whole purpose of this, if you want to set a little title for this section, it would be find the missing side. Alright, that's our direction. So I'm going to first set up my proportion. A proportion has an equal sign, and then we have two fractions. Okay, a fraction on the left of the side of the equal sign, a fraction on the right side. Now what we need to do, we always start off with whichever triangle or shape or figure is first. So this is the first figure, okay, in this case a triangle. And I personally like to pick the smaller numbers. Now I mean sometimes you can't get around, you know, picking the larger number. But in this case I have a 6 and I have a 7. Well, the 6, his corresponding side is unknown. So I'm just going to pick the 7 for right now. So I know that side AC, all right, side AC is 7. And what is his corresponding friend? Well, his corresponding friend is side XZ. So I'm going to put the number for side XZ right here. And right now I'm just putting the letters, but we'll put the numbers in a few seconds, okay? So watch carefully. Now, since I started with this triangle over here, okay, and I need to get the missing side, since I know that the missing side is side YZ, well, his corresponding side is BC. Okay, so I'm going to say, okay, well, here we go, side BC, and then I'm going to put YZ on that side. Alright, so now, looking at the letters does you really no good unless you can see the numbers. At least that's how it is for me. I don't know about you. Alright, so I said side AC, that's 7. Alright, so 7. And side BC is 6. And then we have side XZ, which is 14. And then we have side YZ, which is our unknown. Okay? So notice I've gone from just picking out my sides to writing down my numbers. Alright, now another step, and I'll show you another way of doing this, which is actually the way that I would normally do it, is that what I would do is I just would simply pick out my two sides that I'm using. Okay, and if you want to get fancy, you can color them in. And that way you know which numbers to pick from. Alright, so notice we're picking these two sides right here to set up our proportion. Okay, now let's work this out. So we have, right here, we have two proportions and an unknown number. Well, what was the method that we used to solve a proportion with an unknown number? Okay, so remember, that method was the very cute butterfly method. Okay, butterfly. So we're going to circle the opposing sides. Alright, oops, got a little mess up. Just pretend that's not there. I'm going to scroll down a little so we can work. And then from that, I'm going to set up an equation, okay? So remember, the 7 goes with the x, so I'm saying 7 times x. The 14 goes with the 6, so I'm saying 14 times 6. And really, I shouldn't use the times symbol because it looks like the variable. So times 6. And then I put my equal sign in between. Alright, so I'm going to bring down my 7x because there's no work that I can do with this. And then I need to do 14 times 6. Well, what is 14 times 6? Well, we have 4, we have 2, 6, 7, 8, which is 84. Okay, so 7x equals 84. Alright, so now what we're going to do is next I'm going to divide by 7 on both sides. Remember, I'm just trying to get this variable alone. So I divide by 7 on both sides. These two cancel out, leaving me with simply an x. Alright, let me clean that line up a little. Alright, and when I divide 7 into 84, what do I get? I'll give you a few seconds to work that out. Exactly, I get the number 12. So that means that this missing side right here is equal to 12. Okay? Now let's try another one. Alright, let's try another one. I'm going to set it up the same. I'm going to use the exact same shape. Right? Just keep it simple. But we're going to have different numbers this time. Alright, so get rid of all of that. Alright, nice. So let's say that this time for my triangle I have, let's do 3 and 9. Let's make this side the unknown. And let's make this one, let's do 21. Okay, and now I know that these sides, of course this doesn't look like 21, that doesn't look like 9, that's okay. Actually no, let's change that up. Let's make this the 21. Let's make this the x. Right, and let's change these values to 5 and 15. Okay, so now I'm going to do the exact same thing. I'm going to pick two sides. One of those sides has to be my unknown, and I'm going to use those two sides from each triangle to create a proportion. Alright, so now, using my pen, and I remember, or crayon, remember I told you that there's a method that I would typically use? Well, this is what I would do. I know that the corresponding side for x, for this missing guy, is the 21. Alright, I know that that's the corresponding side. And so remember, I want to pick the smallest numbers I can, so I'm going to just pick the 3 and the 9. So they're small, right? So I know the corresponding side for the 3 is the 9. So those are the two numbers, or the two sides from each triangle that I'm going to use to set up my proportion. Alright, so watch what we did. Alright, so we're going to start with this left triangle because he is listed or drawn first. Okay, so I'm going to start off with my proportion, which is an equal sign and two fractions. So I'm going to put the x over here, and his corresponding side, which is the 21, needs to go across from him. Okay, do you see how we did that? So the x and the 21 need to go across from each other. Alright, the other side that I picked, which was 3 and 9, I'm going to put 3. Oops, let's fix that real quick. Alright, I'm going to put 3 as my denominator and 9 as my second denominator. Okay, does that make sense so far? Alright, so now that I have my proportion set up, I'm going to go ahead and start with my butterfly method, also known as cross multiplication. Cross multiplication is actually the technical name for it, so that's why we need to use it. Okay, so we have x times 9, which is nothing but 9 times x, equals 3 times 21. Alright, so do you see how we have that so far? Scroll down a little bit. So first I'm going to bring down my 9 times x because there's no work to do there. But this 3 times 21, I can go ahead and multiply that together. Alright, which would give me a total of 63. Okay, because 21 times 3 is 63. Now, next step is to divide both sides by 9. Those two cancel out, leaving me with x on my left side equals 7 on my right side. So that means that this missing number equals 7. So finding the missing number is actually a very simple and easy process, okay? So let's move on to something else. Let's move on to something a little bit more fun, okay? Now here we have another definition. In any similar figures, the ratio of the corresponding lengths, including perimeter, so any corresponding length, um, is equal to the ratio of their corresponding sides. Alrighty, so corresponding lengths is equal to the ratio of their corresponding sides. Alright, so we're going to take a look at what exactly does that mean. Okay, so with this definition, what we're really trying to find out and the usefulness of this is if we want to find out how much bigger or how much smaller is one shape to the other shape. Okay, so watch what we have here. So I have my two shapes, my two figures, in this case triangles, and I'm using the same measurements from before. We have 10, 7, 6, 20, 14, and 12. Alrighty. Now what we're doing, what our definition says, let's look at our definition one more time. It says that we have a ratio of corresponding lengths. Now in this case we can include perimeter, so we're going to use perimeter. So the first thing we need to do is figure out what is the perimeter of this triangle. Remember, perimeter means to add all three sides together. So 10 plus 6 plus 7. That gives us a perimeter of 23. And so on this side, I'm going to add 20 plus 12 plus 14, which gives me a perimeter of 46. Okay? Now, notice it said that we can create a ratio between the perimeters and one of the corresponding sides. Okay, so I like the number, well, we can either pick the 7 and the 14 or the 6 and the 12 as a corresponding side. It really doesn't matter. So I think I'm going to pick the 7 and the 14 because I like those numbers. So 7 to 14, that's our first ratio. Remember, a ratio can be written in terms in this direction, or I can write it as a fraction. However, for this purpose, I think it's a little bit easier to write it in this method. It's a method that works for me well. Works well for me. All right, so 7 to 14, so that's one of our corresponding sides. Then I'm going to create another ratio for our perimeters. All right, so we have 23 and 46. So 23, oops, let's fix that up. All right, so we have 23 to 46. All right, 23 to 46. Now, where do I go from here? Well, first thing I need to do is I need to find out, I need to take this number right here, this 7, and I need to divide it into the 14. All right, so 14 divided by 7. Well, that's the easy multiplication fact or division fact, and that gives us the answer of 2. All right, so I took these two numbers and I simply divided them. All righty, so that gave me the answer 2. So that means I also need to take these two numbers and divide those. And when I divide 23 into 46, guess what? I get 2. Now, what does that mean? That means that this triangle right here is twice this, or this triangle, actually, this triangle right here is actually twice the size of this smaller triangle. Okay, or we can say it the other way around. We can say that the smaller triangle is half the size of this larger triangle. But more importantly, notice how when I set up that ratio or the proportion between the ratio of the sides and the ratio of the perimeter, the numbers come out the same. That means, now let me show you what that means, okay? Let me show you what that means. Let's erase this, okay? And I don't have my book on me, so I can't tell you for sure if you would have this problem in your book, but just in case you do, let's do it. All right, so let's do 7 and 21. Let's do, let's make this, yeah, let's make that 3, 9, and let's make this guy, what did I have, 5 and 15. All right, let's say that in your book, and let's just pretend that we don't know how to do this. Let's pretend that we don't know this number right here. Okay, we don't know who this guy is. So let's say that on this side, we know our perimeter. We can figure out what the perimeter is. 7 plus 3 is 10 plus 5 is 15. So our perimeter equals 15. Okay? But now on this side, we don't know what our perimeter is, unfortunately, because we are missing a side. So our perimeter is also unknown. Poor guy. All right, so what is that? What do we do in this case? How do we figure this out? Well, all I need to do is I need to take my corresponding sides, and I have two options. I can either take the 7 and the 21 or the 5 and the 15, okay? And I can set those up as a proportion. Now this time I'm going to write it slightly, well, actually I'm not going to write it slightly different. I'm going to write it the same way. So 5 and 15, let's use that. So 5 to 15. And then we'll set up our proportion, even though we don't know what the ratio is for the perimeter, we'll set it up because we're going to use that to check it. So 15 to unknown, we don't know what it is. All right, so if I divide this 15 by 5, I get the number 3, okay? Which means if I take this 3 and multiply it by the 15, I should get what? Exactly. I should get 45. That means that this missing side, or not really a missing side, the missing perimeter, the perimeter that we couldn't figure out because we were missing a side, is equal to 45. Okay? Now, the way to check this is simply to divide the known perimeter by the perimeter that we just figured out. All right? When I take 45 and I divide it by 15, guess what I get? I do indeed get 3. Oh, pen is having a little problem. Alrighty, so we know that this missing side is 45. Okay? So that takes care of that. Now let's do, actually I think we'll just stop there for today, okay? Because I think it's a whole lot of information to work on, a whole lot of information that you need to kind of absorb. So go ahead and open up your books and begin working on the assigned pages. The main goal is to finish section A, okay? Finish section A. Section B is an extra kind of, not necessarily a challenge section, but it kind of stretches your mind even further. But if you can get section A, then you will officially be prepared for any question that will be, or any basic question that will be thrown at you on the test. Okay, and we'll work on a little bit more of these throughout the week. I might make a little practice video for like a kind of a review day. But anyway, I hope you have a wonderful afternoon, a wonderful morning, and I will see you soon.